Well, so Jeff, you're the only audience member so far.
I think, no, I think a lot of people have joined. I'm waiting for the chat to open. That's my cue that it's time. And then, and that is done kind of automatically by the system. So once that happens, we'll kick off. But no, you won't see anybody else join on Zoom.
Oh, okay.
Everybody is joining through our attendee hub. And so, yeah, there'll be quite a few, I think, on, but
Okay.
there. Okay, chat is open now, so I'll go ahead. We'll get started. Thank you for joining us. We've got a great presentation lined up next, titled Pedaling Toward Innovation and High Accuracy GIS. And this is being presented by Phil Ponce and Nicholas Smilowski. Oh boy, Smilowski. I thought I could say it.
Don't worry, Jeff, you got close enough.
Yep. So take it away. Looking forward to what you have to say today.
All right. Well, thank you, Jeff, for having us today. We are very excited to talk about a project in a different geographic location than North Carolina. So hopefully we keep you awake for the next 30 minutes or so. We obviously, this is a very fast presentation. So if you have any questions, please go ahead and put them in the chat. Jeff will consolidate that and we can address them at the end of the presentation. All right, so I am Nicholas Smilowski. I work with Bad Elf. For this presentation, I'm just going to give some technical support and talk through just a few of the slides. The real man in charge here is Phil Ponce. Phil is the vice president and co-owner of a company called Engineering Mapping Solutions, EMS. He's also a registered principal engineer. So if you've ever met an engineer or dealt with an engineer before, you know what we're up against with Phil. And so Phil's going to be talking through this project of Cave Creek and developing this GIS. So it should be a good time. So moving right along to keep pace. All right, what are we going to be doing today exactly? The agenda, we're going to talk about a couple factoids, give you a little bit of a background to what's going on so you can get a good feeling, tangible feel of what Cave Creek is all about. We're going to talk about the geospatial problem. We're going to talk about the custom solution that fixed said problem. We have some analysis results to back up the claims that we are making. So you don't just think, you know, we're doing, I don't know, we were just using magic to do these things. There's actually hard evidence, qualitative and quantitatively measured. And then we'll do some Q&A, AKA prophetic declarations and questions from Phil at the end, and he can kind of leave us off with his final thoughts. So quickly, I'll let you guys know.
Prophetic was not my word, but go ahead. Go ahead.
Don't let him fool you. So if you might have heard a little bit, but we were talking about Cave Creek, Arizona. So this is a municipality that is on the outskirts of Phoenix. It was originally settled in the late 1800s. And it's approximately 30 square miles large. Like I said, it abuts the northern edge of Phoenix. It's also adjacent to Scottsdale, if you're familiar with that area. Currently, the water and sewer utility system services about 1,600 households, right? So not the biggest municipality in the world, but also not the smallest. I also wanted to throw out that Phil was mentioning earlier, Cave Creek has got a really interesting feel. They are very much so about their identity in the old kind of West. They have lots of moratoriums and special laws in their jurisdiction where you can't do a lot of, you know, non-native building and non-native plants, and they're real sticklers. They want to have it beautiful all the time. And I mean, as you know, as they should. So EMS pops into the scene 1995. So Phil's been doing this, you know, a few years, focusing on the development of engineering accurate digital mapping. And what I know of this is when Phil got into this, he was really focusing on almost using CAD in a GIS manner and kind of merging the two together. So EMS is a leading company in the state of Arizona with emphasis on wet utility database development and custom software deployment. So here we are in 2019. Phil was approached and was working with the town of Cave Creek on a goal to build an accurate GIS that was functionable, scalable, and cost efficient. And it was integrated with the Bad Elf GPS, and it was the custom GIS deployed in 2020. So you have Cave Creek, north side of Phoenix, EMS, been around quite some time doing this type of work. Specifically works a lot on utility database development and deployment, and then engaged with Cave Creek to help them build their GIS up from the ground. All right. Hey, Phil, can you talk to us a little bit about the challenges of the project?
Absolutely, Nick. Thanks. And thanks, Jeff, for having us. At the risk of preaching to the choir, we build GIS from various sources, right? And so since we have been doing it since the mid 90s, a lot of this should look familiar. You could start with engineering as-builts. We had prior water and sewer modeling that were largely schematic in nature, right? Is because they just kind of need to know that a manhole is here and it connects to this other manhole. Spatial location was iffy at best. We had a lot of field markups, various schematic drawings that people would actually draw literally on napkins, but we would take anything that we could get. Ideally, it would be good to just come in and say, hey, let's survey everything we can out there, but the cost of that traditional survey were just way too much. My client Sean, and I'm not even going to try his last name because it's harder than Smolowski, but you can see his quote there. We're working with a system that's over 50 years old, and as most of you would know, during in your course of doing business, when management changes hands, there's not always a smooth transition of knowledge, and you just really have to rely on whatever documents are out there. And if it's poorly documented, you're up against it. And that's kind of the challenge we had out there. So if you go to the next slide, Nick, how did we solve this? Our solution then was to build the GIS from the ground up using whatever documents we could up against an accurate land base. And we're going to talk a little bit about the land-based reality in the next slide. But the idea is do the best we can with documents, following behind with field validation using the GPS measurements, which the approach we're going to show you is very cost effective. Technology has just gotten better and better, and most importantly, less expensive to pull off. And here's the tools that we threw at it. Very ESRI centric. So we're ArcMap, ArcPro, ArcGIS Online. We use FieldMap in the field to collect the data, and the Bad Elf Flex to achieve the high accuracy that we need in the field, as well as the GoPro Max 360-degree imagery and an object viewer that we've built. So you can kind of see that we're kind of commingling a lot of cool technology, and it's just that EMS as a company, myself, have kind of grown up with ESRI and have kept in step with everything that they are offering, and so that's why we're leveraging that with our clients. So Nick, this would be good for you to talk about the reality, because I got to tell you, even back in the 90s, existing aerials just were hard to come by. But the reality that's set by aerials is typically what people gauge accuracy by. And so it's good to have one reality. In other words, a land base that fits the aerials. So people, when they visually just look at this product and say, wow, that makes sense. You don't have parcel lines running down the middle of buildings or down the middle of streets. And so GDAX was a control set that Maricopa County here in Arizona did. And Nick, if you could pick up from there, because GDAX is kind of important to the reality.
Yeah, so putting on a more of a geodesist surveyor's hat, the GNSS were they're managed by Maricopa County, and they are the cornerstones, or the linchpins of the entire land base that Phil was discussing. Based on top of those points, and imagine that surveyors ran out and put caps and registered it, and you've got these things are in section corners or in middle of roads all over the place, shotgunned literally over the valley of the sun. On top of those GDACs or monuments are the parcel base. So, the parcel was built from there. Then you have the aerial based on that as well. And so what happens is Maricopa has kind of this, quote unquote, one reality that everything needs to really kind of match to. And so whatever data Phil wanted to collect in the field to build into the GIS for Cave Creek, it needed to match that reality. And the way he went about doing it is utilizing the Bad Elf GNSS. Now, I do want to make a mention that Phil, and he should probably talk to this, but I'll jump in. But Phil tried several GPS units, and the reality is those other units would probably have done very similar, in the atmosphere here. They probably would have worked. But with his research, he ended up going with the Bad Elf unit, and that's where Phil and I crossed paths on this endeavor. And so what we mean by that reality is that the Bad Elf produces data that matches the GDACs. I mean, if you've been in GIS a while, we talk through projection systems and transformations, things like orthometric height versus geoidal height, and the flex matches all of those things. So, Phil, here is the methodology of all of those disparate systems that you integrated. Can you quickly run through this?
Absolutely. If you look at the bold red, that all the pieces basically break down into three components: the collection, the editing, and then finally the deployment. So if you draw your attention for a moment to the collection, in that box, we have the Bad Elf unit. It kind of starts it all. And we're collecting the GPS, we're processing it on a, in this case, an iPad that has the Bad Elf software that commingles the Bluetooth signal from the Bad Elf with the AZ cores maintained by our Department of Transportation, is an RTK correction service, which, by the way, is free. So all of a sudden, I have an RTK corrected position that, in the worst case, still less than a foot; on its best case, less than a centimeter. And unbeknownst to ESRI Collector just says, hey, send me a point. And for the most part, I'm centimeter or better all day long as I'm riding around on my bike. So at the end of the day, what we're looking at is just collecting data and pushing it into the GIS via ESRI Collector. We happen to push this one up to the data hub, which Nick mentioned that I'm an AGIC member. AGIC is a statewide organization that manages the GIS data for the state. And they, as part of their mandate, are actually providing through ArcGIS Online access for all the cities to have free licenses. I think they have 3,500 licenses they're doling out. Well, it works perfect for this because I'm pushing ESRI Collector data up to AZGeo. We then edit it with Arc Pro and publish it in Arc Server. So finally, on the deployment, then we're using either Web App Builder for the lower end tools that'll allow us to publish the data to any device. And then the more sophisticated is using the EMS Web Map software that I've written that leverages ESRI's JavaScript API. So gosh, I'm telling you, there's a lot more. We could spend the rest of the time on this slide alone giving you the details, but that's it in a nutshell. We collect, we edit, and finally deploy.
Awesome. Just due to time constraints, we're going to run through this super fast. This is just representing where Phil was collecting some data being displayed through the AZ Geodata Hub that is run by the Arizona State Land Department. And then you can see that same data also, as Phil mentioned, deployed in his custom web app, where he is actually going in and helping the utilities based on what he has found, really locate everything that they've got. So now we get to the fun part. So you might have caught that Phil said something about a bike. So Phil, why don't you tell us about BikeRAC?
So if you look closely, that's me on the bike. I should point out that my intent was to get this all staged up so that one of my technicians in my company could take over and run around in the field. But I got to tell you, I got to doing it, and I just enjoyed it so much that you really couldn't get me off that bike. And the idea here is that we have the Bad Elf, as you see, affixed at the top of a survey pole that's aligned with the point at which the tire hits the ground. So all I was doing was lining up over the top of a position I wanted to take, and using the ESRI collector, punch in the necessary information. And it's not shown here, but we also mounted a GoPro camera to the system. And one of the other pictures may have it. In fact, Nick, if you go to the next one, I think it does have it.
Yep.
This is the point. Well, there we go. Yeah, let me talk about this real quick before we leave it. You'll notice that on our daily log here, I was logging the time we spent in the field, the number of points collected. Look down that column at points per hour. I mean, it is just phenomenal, the number of points we were able to collect. And you can see on some days it's 200. I mean, that's obviously in like multifamily, I could zip around real quick. Use an average of anywhere from 80 to 90 points per hour, and you can kind of see just the magnitude of the work that we could get done.
I should throw out there too that Phil was not just collecting the positions of the points; he was entering in unique attributes into different attributes that were requested from the client. So it's not just taking the point and continuing on like a topography shot, but actually doing asset collection. Here you go, Phil. So I see the camera on the top.
Yep, and that's what we were mounted to get the 360 views. And I think the next slide is just more of the same. The next slide, Nick, shows just the coverage area of what I covered, and that's the trace. What's more interesting is this next slide. Those are the actual GPS points, and you can see the asset types that we collected, and just the sheer number of points that were collected. And it's again literally connecting the dots. We get out there, we collect the point, as you can see on the map here, and then my technician follows in behind and starts drawing the information in ArcGIS. This is an interesting slide here, only because, as most of you know, that when you have GoPro, it has a built-in GPS. And it's a little hard to see on this slide, but the cyan points are where the GoPro GPS thinks it's at, and the Bad Elf track is the high accurate sub-centimeter trace. And so, Nick, I think it'd be interesting if you could just share your thoughts on why that is, and just kind of the value of why we brought Bad Elf into the picture.
Yeah, no, it's basically the difference between a consumer GPS accuracy and a professional GPS accuracy. And so the GoPro will get you close, but if you're actually wanting to do authoritative data collection, you're going to need a GPS that's using multiple constellations, satellites. It's the difference between a Honda Civic versus a Lamborghini in terms of what those different types of GPS can do. So I see this little picture on the bottom, and it reminds me of, so this is what you were collecting with that 360-degree imagery. And as far as I know, that 360-degree imagery was tied down to the points, like you said, Phil, and you were able to create a custom solution using all of this. Can you maybe talk about your web viewer here?
Well, this is what we're calling Ems Field View, and if the previous image is what it looks like raw, and you can see it's somewhat distorted. It's called equirectangular, I think is the term. And so the viewer that I wrote in the next slide takes that strangely apportioned image and turns it into a sphere. So all of a sudden in this view, you can use it just like you would Google Street View. And you have the added benefit of seeing where you are on the map. And then we can also pull that into yet another application that allows us to extract assets from those features. And so what Nick is showing you here is various ways that we do pulling assets off of imagery. We do sidewalk assessment. You can see that by having very accurate positioning of your pictures, it just opens the door to all sorts of cool opportunities to leverage this data. And so, yeah, here we go. In the interest of time, we can put a wrap on this and address any questions that people may have. Looks like we got about 10 more minutes. So what we do, just like we said in one of the earlier slides, we do the collection, we edit it in the ESRI ecosystem, and we deploy in various ways, including the EMS web map. What we try to do then, in a nutshell, is leverage the best tool for the job. And we just leverage the best of what Esri has. And Esri's continually to evolve. Just even in the course of doing this project, they've come up with some new offerings that used to be called Collector, now it's called Field Maps, and they're weaving in other things, other offerings, and it just continually grows. And you know, on Nick's side with the GNSS technology, that's continuing to grow. So it's a pretty exciting time to be in this field. We enjoy it, and I'm at the age where I should be retiring, but I just can't get away.
That's awesome. So talking through a little bit of the validation of what was going on, at the beginning of the presentation, we mentioned that we did a lot of testing. Phil did his due diligence. He went out and found data sheets on USGS monuments, took several GPS, including the Bad Elf, and tested it and saw how easy, or how difficult getting these types of accuracies were. I also want to throw out there that from this high accuracy collection, Phil's company was able to really come in and clean up the database. And so, Phil, can you talk a little bit about how what some of the scenarios, like in the next few slides, what you ran across and what you were able to fix with this solution?
Well, what's interesting to point out on this picture, that valve record that you show on the left was probably done in the 60s. And to the extent that they're able to find valves, a lot of times they're buried. They were going off these valve records, and so we would come in and with the high accuracy GPS get the locations. And what I was able to sell them on is the fact that, guys, we can get out there and correct your GPS. The panel on the left there is the GPS before it was corrected, and you could see the locations of where the things are supposed to be, and we moved them over there. On the right is just an example of how close we're fitting to the county reality, and that's just a sewer manhole that I collected. And so it just gives the client the confidence to say, hey, you know what, this you guys are really adding to the value by this GPS system. And you can kind of see just the various ways that they're doing business. This actually here is an extract from an email sent over. So now they purchased a GPS unit for the field, and they're actually out collecting information in the field and telling us how to edit the GIS. And we're slowly migrating to where they're going to maintain their own GIS. But in the meantime, they're out collecting GPS points and telling us what to do with it in emails like what you see here.
So let me make sure I got this correct so everybody out there in digital land can understand this. So Phil was his company was hired to come in and create this database that was scalable and robust. Part of that was cleaning up old records, but part of it was also collecting new assets. That's where the BikeRAC came in. He went and did a mass collection, but there were still gaps in the data, right? And so then what Phil is showing us here is the town of Cave Creek also purchased a GNSS system, and then ran out and filling in some of these gaps with this data or these data. And what's happening is EMS is collaborating almost near real time with them based on these web applications, emails, telephone calls, weekly meetings. And as this information is coming in from Cave Creek, Phil's team is adding it and aggregating it to the database and the GIS and making sure it's authoritative. And so you've got this really cool bi-directional atmosphere that, collaboration is king. So I can read this quickly. Cost. Traditional market research exemplifies that a traditional registered surveyor would charge between $80 and $100 per field collected point. Using this math, the town of Cave Creek estimated they would have to spend about $350,000 to complete the project. However, with EMS's innovative geospatial solution, the project cost dropped to just over $15,000. Caveat to that, I don't think, and this was from Phil's client, the town of Cave Creek. I don't necessarily think you need to have a registered land surveyor collect every water valve out in the system, but that's the way that they were estimating it. And for $15,000, I mean, you can't beat the amount of data that were collected. We are almost out of time. So if you have ever heard or have not heard, there's a lot of podcasts and webinars out there these days. This is a podcast called the Geoholics. You can find them on Spotify. You can find them on Apple. They're also through their website. But they focus on all things geospatial. Episode 65, a number of weeks ago, Phil and I did a 1 hour long discussion about this project. So if you want to have a fun podcast about geospatial things, check out episode 65. There's some more information from Phil and I about this project. I'd also recommend reach out to Phil as well. That's phil@emsol.com. Phil loves to talk GIS. As he said, he's trying to retire, but can't for some reason. And so if you have any questions about the solution, about the different parts, whether that's the Esri piece or the Bad Elf piece or the GoPro piece, you let us know. I mean, we are here to help. Phil, any last prophetic declarations?
No, I think we better toss it back to Jeff because I think we're almost out of time.
Yeah,
All right.
excellent job. Excellent. Very interesting and informative. We do have one question. So there's so far, if anybody has another question, we've probably got a minute or so if anyone wants to type something in. But Ben says, this is great. Glad to see a bike used in a geospatial application. What did you do for features that were not flat and able to be rolled over with the bike wheel? And I think that's when you were talking about the rack.
Yep. That's a good question. There are times when I had to get off my bike and I use a wheel and wheel out. There's also people that don't want me in their yard at all. So I had a laser gun and I would approximate the distance with the laser. And as part of data entry into collector, I would record that information and the offsets, and at edit time, the technician would take that into consideration when he's building the GIS.
Well, I would think the town felt like they got a really good return for their investment there. How that worked out. Was there kind of a point at which they were, realized that your work and your product was, saved the day in some way, or made it available for them to do things that they wouldn't otherwise been able to do?
I'm not exaggerating when I say every day. I'm on I can't tell you how many times that we're both online in a collaborative effort, and we'll just cruise along and he'll say, oh, look, I see you saw that meter. Oh, you caught a blow off there. And it just forever tells the story of what you can see out there, and it helps decision making every day. Mm-hmm. I am not exaggerating, and it is a very good feeling, Jeff, to know that the work that we've done can help them that way.
Well, thanks again. And I didn't know about the Geoholics podcast. I'm going to check that out. So thanks for letting me know about that. Ben responded saying he has worked part-time for a surveyor and can imagine your workflow and what you're having to do there. So Well, guys, great presentation. We actually, if it's okay with you, we are recording these and we're going to put them on YouTube in a couple weeks. So they will be there for people to see as well. And so really appreciate your time and everything that you've imparted to us today.
Thanks for having us.
I'm going to close, and we've got another session coming up right after this, and encourage people to jump into the next session. Thanks again. I'll take